Welcome, rather an humble welcome to this new session of economics class. In the last class, I had explained producer's equilibrium through minimization of cost. There we had seen what the conditions are being fulfilled at this point E, and we too had seen that at this point, this is the equilibrium condition, that ratio of marginal productivities of two factors must equate the price ratios of the two factors. Same condition or the same conclusion would be drawn if we maximize the production or maximize the profit. So today's class we shall be explaining maximization of production at the point of tangency. So as before, this is the point of equilibrium where IQ is absolutely tangent with the isocost line, and we have the equilibrium. Now this point is today to be explained by maximizing production. Here is the standard question, maximization of this. This is production function, and here cost becomes constraint. So while we were minimizing the cost was variable and the production was constant. Today is the just reverse case. Today this output has become variable and cost has become constant. That's why it is acting like a constraint. So this is the constraint of cost, and in figure it is called as isocost line. Now with the help of these two equations so now we have the Lagrange function. This one is acting as the Lagrange function. Now first order condition requires that the first order partial derivative of phi b with respect to k, l and lambda is being equated as 0. Now first of all, we just differentiate v with respect to l, that is delta v by delta l. So the very differentiation of this production function with respect to l minus L has the one differentiation, so minus lambda PL 0. Secondly, dv by delta V by delta K. Now this minus lambda and K differentiation 1, so lambda Pk. Here we have lambda Pk, and thirdly delta V by delta lambda, the entire one lying within the parenthesis. So now from equation 1, this is the equation 1, delta FKL by delta L, and if it is taken to right side, it becomes lambda PL. Now this is the first order partial derivative of production function with respect to labor. So this is marginal product of labor. So MPL equals lambda PL. So lambda is MPL by PL. This we have got from equation 1. Now come to equation 2. This is equation 2. Lambda FKL by delta FKL by delta K equals lambda PK as before. This is first order partial derivative of the production function with respect to K. So this is marginal productivity of K equals lambda K. So lambda is MPK by PK. Thus we have reached the same conclusion and the same condition that at the point of tangency, that is at point E, this equality holds, that is the ratio of marginal productivities is equal to the price ratio or MPK and PL by PK, or this could be expressed as this one. So MPL by PL equals MPK by PK. Both are the same statement. Now second order condition requires that at this point of tangency, IQ must be convex, and to show the convexity of isoquant, we should have this condition: diminishing marginal productivities of the two factors, and it is a very product of these two marginal productivities must exceed the square of cross partial derivative as before. This remains constant for in all the three cases. So this is what we have reached at this conclusion through maximization of production, and this is the theoretical part of this. Next we shall just be solving a sum on this problem. This is the sum. We have the production function Q equals under root LK, and these are the given conditions: price of labor 20, price of capital 10, and this C640, this shows that the producer is likely to spend 640 rupees on the production of Q. This is what it means. So now find optimum level of output for the given cost. Absolutely, this relates to this problem, and now we must start solution The problem is maximize Q under root LK subject to, is this 10? 20L plus 10K is 640. This is the isocost line, L into PL plus K into PK, that is C. So the producer for whom per unit labor charge or the wage rate is 20, the interest rate is 10, and altogether he wants to spend 640 rupees for the production of Q. We are interested in knowing that with this cost condition, what will be the maximum level of Q to be produced. So now the Lagrange function, as before, V is under root KL plus lambda into 640 minus 20L minus 10K. This is what our Lagrange function is. Now the first order condition, delta V by delta L root K by 2 root L minus 20 lambda 0. This is differentiation of this one with respect to L. Rather, we have differentiated root L, root K remains there. Delta V by delta K, that is root L by 2 root K minus 10 lambda, it is equal to 0, and delta V by delta lambda 640 minus 20L minus 10K 0. We have got the three equations. From upper two equations, we have to find the value of lambda. So from 1, 20 lambda is root K by 2 root L. So 40 lambda is root K by root L, thus lambda is root K by 40 root L. From 2, 10 lambda is root L by 2 root K. तो ये lambda हो गया, this is root L by 20 root K. This is lambda, this one is lambda, these two has to be equated. By equalizing these two values of lambda, root K by 40 root L is root L by 20 root K. By going cross, we have 20K is 40L, hence K is 2L. This equality has to be put in equation 3. So from 3, here is the third equation. So if we change the side, 20L plus 10K becomes 640. Now we have to put the value of K. So it is 20L plus 10 into 2L is 640. So 40L is 640. So L is 16. We have got the value of L, and right through this value we can get the value of K. Hence K is 2L, that is 2 into 16, so 32. Thus we have labor should be 16 and capital should be 32. This answer can also be checked through This constraint 16 into 20, 320, and 10 into 32, 320, and the summation of 320, 320 becomes 640. So answer is correct. And while solving the sum, we have to simply show the conditions of second order condition, that is FLL negative, FKK negative, and FLL into FKK must be greater than F square LK. Well, simply this condition has to be shown. So if we come down over here, labor was 16 units of labor, 32 units of capital, and this the value of maximum production we can also find out. Maximum Q root KL. So under root 32 into 16, under root 512. And this 512, right? Get the value of 5. थोड़ा सा on कर दीजिए यार. This stands the maximum Q. So this way, with the given cost constraint, we have maximized the production. We have got we have proved the conditions, and this sum has been done based on this. Now, in next class, we shall be maximizing profit and shall be reaching at the same conditions, and this will be the final way of explaining the producer's equilibrium. So in the next class, we shall be explaining profit maximization in producer's equilibrium. This is all for today. Thanks.